Hi everyone, hello teacher Trần Ngọc Đám. Let me introduce myself. My full name is Nguyễn Ngọc Hậu. My student ID is 19146329. I'm a junior and my major is mechatronics engineering in the faculty of mechanical engineering. As you can see on the screen today, I would like to present my research paper with the title Develop Interactive Mobile Robot in a Dynamic Environment. Nathan Rusher. And my presentation today is divided into 4 parts. The first is introduction, and the second is the methods, and the third is results, and finally is the conclusion. Okay, let's move on to the first one, introduction. As you know, currently robots partially can interact, navigate, and execute missions. We are living in an environment that changes every time. For example, people are moving around, stock prices go up and down, or a new table is added to the room, and so on. So, the robots must be able to adapt to this. There are many ways to handle it, but one algorithm that is often used is SLAM. SLAM stands for simultaneous localization and mapping. However, robot operating systems have much available SLAM algorithms. To find out optimal solution, we will compare among algorithms and then choose the best one. Okay, next, we move on to the meta section. First, in order to a robot can operate, we have to build robot operating system, including 3 main modules. Number 1, human-robot interaction. Number 2, SLAM and navigation. And number 3, manipulation. For robots to interact with humans, that must do the same way human interact. It means using sound to communicate with each other. Specify that is for control block include to pass speech recognition and sound synthesis. The next one, in order to a robot can self-navigate and cross obstacles, we use SLAM algorithm to create the map and localize itself. The last one is manipulation. The robot will recognize, take, and deliver objects. Even if possible, the robot has to recognize exactly the customer face. As mentioned before, human and robot interaction include to pass speech recognition and sound synthesis. In speech recognition, we use a library to convert sound into meaningful text. For example, when a customer commands the robot to give him a cup of tea, the robot will receive and process this sound. The robot can understand human language. This principle is based on the principle of keyword spotting. In sound synthesis, we use a sound synthesizer package in rows. After the robot receives an order, for example, it can give its response or instruction. The robot say like this: "Thank you for the order. Please wait a minute." And we can program with C++ or Python language. Okay, now let's move on to the SLAM and navigation. SLAM and navigation are essential for a robot because currently robots have the ability to self-navigate without any human intervention such as remote control. And there are four different SLAM algorithms. Number one, tree mapping. Number two, hector SLAM. Number three, cartographer. Number four, automap. To can use SLAM, we need the leader, sensor, and volatile. And then use simulation software to record the map words created. Okay, now we go to the next point, which is manipulation section. As mentioned before, the task of this block is to assist the robot take and deliver objects. If possible, the robot must recognize the customer's face. So, manipulation bus has two main points: object detection and face recognition. Object detection is a technique of finding a particular object in an image. Find object 2D library is used for object detection. About face recognition, they are based on hardline features proposed by Viola Jones. We use LBPH, stands for local binary pattern histogram, as for face recognition. And the supporting software is OpenCV. Okay, we move on to the result section. I want to show you simulation results. To road tree mapping, we have performed using rows, gazebo, and Arvis. Later, we executed using a real robot. In this experiment, leader and odometry are used. The result is shown in figure 8. This is the map that were created when using tree mapping algorithm. For automap is 3 mapping technique, and the working principle of leader is based on melody. Figure 9 represents the map obtained from simulation in Office. Figure 10 shows a physical representation of the world using automap in Office. For cartographer, figure 10 represents the map created using cartographer. It is difficult to tune. We have yield leader and odometry for the algorithm to produce a map. For hector SLAM, figure 11 represents the map from hector SLAM. Hector SLAM is easy to tune, however, it may cause some problems with sharp corners. This is the table comparison of SLAM algorithms. Is shown in table 1. As you can see, because AutoMap has bad results, so it were eliminated from the table. So we have 3 algorithms in the table. About mapping ability, tree mapping is the best cartographer rank 2, and the last is hector. About tuning, hector is so easy to tune, cartographer is very difficult to tune, tree mapping at the medium level. When meeting sharp turn at the junction, hector will slot trajectory, tree mapping and cartographer still grip the road excellent. In short, tree mapping algorithm is the best choice. In conclusion, I'll summarize my presentation through the following main points. In this paper, the author showed a design system for a robot which have the ability to communicate and navigate intelligently, and they carry out and show sound recognition and sound synthesis module, and they also implemented differently same algorithms. They compare the results and show their performance in a real time in an indoor environment. Besides that, they also introduce the way how to enable their robot to undertake different missions. That's all. Thank you for listening.